So we said we'll have a look back at question 10 in 4A. So 4A10 is probably the best way to write that question. This is in Dominic Donnelly's chapter on relative velocity in his book Applied Mathematics, and we're on page 116. So what we have here is two cars, X and Y, moving along straight roads, which are at right angles to each other. Uniform velocities 5 and 8 meters per second respectively. The two roads meet at a crossroads C, and when Y is 100 meters away from C, X is at C. So I've read it and I've decided what I'm doing. So Y is out here heading in a positive I direction at a speed of 8 meters per second, and the X particle is here and it's moving up here, and its velocity is 5 meters per second, and that's obviously in the J. At this time we are told the Y is 100 meters from this point that X is currently at. And so what we want to do is we want to find out in relative motion when the two vehicles are within 75 meters of each other. That's what the question says. We can see that it's outside that at the moment. It's 100 meters distance, but with Y going in at 8 meters per second and X leaving at 5, there's a possibility. And so if we assume that, say, at this stage here, when Y is here, and we assume that X is here, well, the distance the 75 meters corresponds to will be a line like this. That line there is made of two quantities, two orthogonal quantities. This one here, which we could describe as being the distance that X travels, and this one here is the distance that Y travels towards the 100 meters. Is that okay? So let's just make two phrases for them. So S of X, well, that's quite simple because X is at this point O right now. So if I say that S of X will increase from that distance at 5t, that means its velocity by the time. The time should be counted in seconds as it's meters per second. S of Y. So, excuse me. S of Y, it's currently 100 meters from there, but it's closing in on that at a quick pace. So we can say it's 100 minus 8t, and the 8t coming from Y moving at 8, and the t in the seconds. So what we have is this distance here and this distance here. This is algebra and these are variables, and so these may change. Looking at this, it's a right angle triangle, and we can introduce Pythagoras' theorem, and you know that is h squared is equal to o squared plus a squared. In this case, the hypotenuse, we're actually only concerned about a certain time, and that's when h is 75. So we can say 75 squared is equal to o squared. Well, o squared, if you don't mind, I'll call it 5t squared, and plus 100 minus 8 times t, and that has to be squared too. So 75 squared is 5625. 5t squared is 25t squared, plus 100 squared is 10,000. 8t squared is 64t squared, and then 100 by minus 8 gives me minus 800, and 8 by minus 100 minus 8 by gives me minus 1600 t. You've probably done that sort of work before, so that's what this is. So we need to add it all up, and you should recognize this as becoming a quadratic. So the t squared makes it 89t squared, minus 1600 t, and then 10,000 minus that 5,600 gives me 4 plus 4,375. That's all equal to 0 because I brought the 5,000 across. This is a quadratic. There's quite a common, well-known formula for solving quadratics, and that's called the minus b formula. That's really what started this. So the formula is given as minus b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Now, it's quite a nice bit of maths to derive that, and what it is as you would have done solving factorizing quadratics before, or maybe simpler ones. In some levels of study this will fall out, and maybe I could do a video on that again, but I'm sure there's videos on that, and there's definitely web pages that will explain step by step on how we get through that. But the crucial bit I want to explain is how to use it. So this is really a by, I'm going to say x squared minus b by x plus c. So instead of x's, I've actually got t squared. So you've probably solved it for x before. So this is the same, it's just solving for t. It's going to give us two values for t, t1 and t2. Then they might not both be acceptable. In fact, neither might be acceptable, but probably an error at that stage, but we'll fill it in. So minus 1600 is plus 1600 plus or minus the square root of b squared, which is 1600 squared, minus 4 times 89 times 4,375, and all that is over 2a. Again, if I can go back to my labeling tasks, this is the most important thing, or the first thing we need to do. Then we can add it and subtract it from this, and then we can divide. And we can do all that on one line. So I'm just typing this in the calculator. And so that leaves me with a huge number. If I just get the root of it, so it's 1,025,000. So just get the root of that. It becomes 1001 plus or minus 1001.25, and that's plus 1600 over 2a. So 2a is 179. So 1600 plus that, divide that by 179, gives me 14.53. So that was with the plus. So now we're going to go with the minus. So 1600 minus 1001.25. So now I should be shown there. Yeah, 598. So that's the gap between these, so using the minus sign, and then divided by 179, and that gives me 3.3449. It's times this you need to read it. When you're doing applied maths, especially, you need to read into significance of these numbers. What's this saying? Well, if we want to see what it says, we need to go back to say what we did. We went back here to say that h squared was equal to o squared plus a squared. We put in a figure of 75 for h, That was the limit given to us in the book. This was the changing distance of x. This was the changing distance of y. I showed you here that this was this length and this was this length. So what these two times are, is these two times are the times when SY will be 24 meters along, so it'll be about there, and this will be 15 meters, so I'm guessing this, but making it up completely. So that's going to be your first line, and that's 75 meters, and then later on at 14 I think it works out to be over here and up here, and that's 75 meters. So in all the time it takes for y to go, I'll go mad, all that time takes y to go there, and all the time it takes x to go there, they're within 75 meters of each other. So come back to the significance of these points. This is the first time it is 75 meters. It was greater than 75 meters, it hits 75 meters, and it must be less than, and then comes back out. This is the last time it's 75 meters or less. And so the question was, calculate the time interval. So that's easy enough, right? 14.53 minus 3.3449. And that turns out to be 11.2 seconds within the within 75 meters. So in recap, draw the diagram. You're trying to get any sort of information you can, looking for maybe triangles if you can. Use all the rules you've ever learned in maths before. They all apply. This is the bit that I wanted to work on right now in this. I hope that makes sense. It is just about filling in the appropriate values from here. And whittle them out, and sometimes you get a minus answer, sometimes you get two minus answers. Whatever you get, and that's about it. So I trust that's okay. See you the next time.